Well, thanks so much. I'm Josh Goodman. I'm an economist. I sit over in the Department of Economics and here at the Wheelock College of Education. And I'm going to talk about the intersection between heat and learning, which is a topic that 5 years ago I wouldn't have thought even really existed. Next slide, please. So I'm going to talk to you about a little bit of evidence about the question of how does heat affect students. So we know that heat makes it harder to concentrate, so that if you take a test on a hot day, you get a lower score than you would otherwise. But the question is, does heat have longer lasting effects? Does it actually interfere with your ability to learn in the long run? And whether heat does affect learning has implications for the way that climate change will impact economic growth, because economic growth these days depends very heavily on human capital and the accumulation of knowledge. And so I'm going to talk to you about two published papers that we've written in the last few years, in which we try to tackle this question, which is empirically difficult, because if you compare students who are more versus less exposed to heat, you're not going to be able to identify the causal effects of heat, because students in hot areas of the country or the globe differ in all sorts of ways than students in cool areas. So we're going to tackle this in two ways. In the first paper I'll tell you about, we're going to take data on 10 million PSAT taking students who retook the exam, who took it twice over 2 different years, and we're going to compare themselves to each other over those 2 takes, to compare the same student to himself or herself over those 2 takes. And in the second paper, we're going to take data on the universe of all US school districts, as well as all countries on the globe that take the PISA exams. And we're going to compare each district and country to itself over time. And the idea is we're going to estimate how the same student or district or country performs on these exams after the prior school year is a hot one versus when they take the exam after a prior cool school year. Next slide, please. So in that first paper where we study US high schoolers, it turns out we find really clear evidence that PSAT retakers, these students who take the exam once at the beginning of 10th grade and then again at the beginning of 11th grade, score worse on whichever take was preceded by the hotter school year. So that's already an exciting result. The same student does worse in the year that was hotter. It turns out, maybe unsurprisingly, that extreme heat is worse than moderate heat. We've shown you a little graph of sort of the individual temperature bucket effects here, with the effects of heat increasing linearly with temperatures above about 70 degrees Fahrenheit, and interestingly, no clear effect of cold weather on PSAT scores. One really neat thing in this work is we can show that it's only heat on school days that matters. If you have a hot weekend or a hot summer, turns out those don't have much of an impact on student learning as far as we can tell. Next slide, please. Then when we look at data on the universe of US school districts, 3rd through 8th graders taking standardized tests as part of state assessment systems, we see on the left there a graphic that shows us that we see exactly the same pattern we saw with the US high schoolers, which is that hot school years lower the scores of these younger US students, and particularly more for Black, Hispanic, and low-income students, which is actually also consistent with the PSAT data I just spoke to you about. At the right, what I'm showing you is that same pattern even holds internationally, with countries doing worse than their own performance in other school years when they are exposed to unusually hot periods leading up to the exam. Next slide, please. And so if we think about, sort of what does this all mean, we have, I think that the bulk of this evidence is consistent with the fact that heat is likely reducing the efficacy of learning time via physiological impacts on students and teachers, making it harder to focus. We don't really have direct evidence of that, but it's the hypothesis that's probably most consistent with these results. We also show, particularly in that first paper, that school air conditioning appears to mitigate these effects, although I think more work has to be done on this front. Heat's impact is clearly most negative for students with the fewest school and home-based resources for adapting to temperature shocks. Again, students in low-income school districts or from low-income homes are particularly harmed by these hot school days. And it turns out when we do the sort of calculations about this, the magnitude of these effects suggests that hot school days account for about 5% of the Black-white achievement gap in this country. And all that suggests that investing in school infrastructure likely will improve equity in terms of educational outcomes, and likely has positive social benefits given what we think of as the economic returns to this improved human capital. So I've been really glad to work on this agenda over the last few years, and particularly struck by the extraordinary consistency of the results we're seeing in this area, that heat, in addition to having all of the kinds of physical and mental health impacts that others here have documented, clearly those impacts then affect other kinds of outcomes we also care about, including student learning. Thanks very much.